already we have covered. The next concept, relations, already we have covered. Today we are going to start with the concept of functions. Okay, functions we will be starting today. If you are having any confusion in any question which is related to Cartesian product or which is related to the concept of relation, please let me know. Okay. Functions we are going to start. So what is function? We understood that relation is nothing but just the subset of Cartesian product. There is a certain condition and few ordered pair are there which is fulfilling that condition, that is creating the set R, that is the relation. Okay. Function means all the relation will not be function. There are few relation which will fulfill the criteria of function. Now, what is the criteria of function? So suppose we are having this mapping diagram. Here we are having 1, 2, 3, 4. Here we are having A, B, C, D. If each and every element of the first set, let's say this is set A and this is set B. If each and every element of set A is having one image, okay, 1 is having one image, then 2 is having one image, then 3 is also having one image, and 4 is also having one image, then we will say it is fulfilling the criteria of the function. Now let's say, suppose another example I am taking. Here 1, 2, 3, 4, 5, and here A, B, C, D we are having. 1 is having one image as a A, 2 is having one image as a B, okay, 3 is having one image as a C, and 4 is having one image as a D, and 5 is not having any image. That also we have seen in our relation. We will be taking those examples also. This type of scenario also we have seen. This is not a function. Each and every element of the first set must have its image. The output which we were saying in the previous class, we can also call it image. Okay, each and every element from the first set is having its image, its output in the second set, and then only we will call it a function. Is that the only criteria to be a function? No. That is not the only criteria. Suppose here suppose let me take one example. Just a second. Yeah. Let me take one example. A, B. Here we are having 9. Here we are having 4. Here we are having 25. Here we are having 5, then 3, then 2, then 1, then -2, -3, -5. This relation we have already taken in the previous class also. 9 is related to 3 also, and 9 is related to -3 also. Okay. 4 is related to 2 also, and 4 is related to -2 also. Okay. 25 is related to 5 also, and 25 is related to -5 also. We have taken this example. This question we have already solved in the previous class also. We were writing what will be the relation R in set builder form. So we have written R is the set of all ordered pair XY. Can you tell me what was there? How X and Y are related with each other? Yes, Alina, Ali, Nofal. Can you define this relation?
Yeah, the square of the
X is the square of Y. Can we say X belongs to set A and Y belongs to set B? Can we say? Can we? Can we?
Yes, ma'am.
So this is how we can define our relation. Now the question is this relation is a function? So here each and every element of the first set is having its image, but it has to be unique image. Okay, 9 is having image 3, 9 again is having image -3. So this is not function. This is not function. You can take function in such a way that suppose we are let me take one example which you will be able to relate. Yeah, suppose you are having one remote, okay, or maybe one switch. You are clicking, just you are pressing on or off on the switch, and like two different thing is happening. It is not possible. Let's say we just turn on one switch, light is also on and fan is also on. It is not possible. Okay, one element cannot generate two outputs. If it is generating, it can be relation, but it is not a function. Okay, so the definition of function you can see in your book. It is clearly written in mathematical language that f is a set A and set B is called function only if every element of a set A has one and only one image. If every element of the first set has one and only one image, then only we will call it a function. Okay, to be a relation there was not that such criteria, but to be a function there is a criteria that every element must have a image. Okay, every element. In the previous example we have seen that 5 was not having image, we call it's not a function. So every element of the first set must have its image, but that image has to be one and only one image. There has to be one image only. Okay, here in this relation 9 is having one of the image as a 3, 9 also having one of the image as a -3. This is a relation, but this is not a function. Okay, we will be taking few more example and we will check that. So these are the criteria to be a function. Every element must have an image, and one input cannot generate two different outputs. One input will not generate two different output. That is the condition. Now let me take one more example. If suppose we are having this mapping diagram, 2, 3, 4, and here we are having 1, 2. Okay, 2 is going to 1, 3 is also going to 1, and 4 is going to 2. Now previous one was not a function. Previous one means one input is generating two output. We are just clicking on one of the button and two different thing is happening. 2, 3 different output we are able to generate at the same time. That is not a function. That is not a function. Okay, one input cannot generate two outputs. Now this is a function. Is it possible to like say that it's a function? So here you can see the each and every element is having its image. 2 is having image 1, 3 is having image 1, 4 is having image 2. So the first criteria is getting fulfilled. Each and every element of the first set must have its image. So yeah, each and every element is having its image. Now the second criteria, one input cannot generate two different outputs. One input is not generating two output. However, two input are having the same output. This is acceptable. Okay, this is a function. Now you can understand it this way, that you are pressing the switch, light is on. Okay, suppose this one is light. You are pressing the switch, light is on. You are pressing the remote, there is a remote also, and again light is on. This is acceptable. Okay, this is acceptable. But one input cannot generate two outputs. Okay, getting it? When to call it function and when not?
Yes.
Let's take few questions. We are having one set. Okay, 2 1 ordered pair are 2 1 5 1 8 1 11 1 14 1 17 1. Check it whether it's a function or not. How to check it? Draw the mapping diagram. You will get the idea. Draw the mapping diagram. Clearly, you will be able to see whether it's a function or not. Draw it. Is it a function, the first one? Alina, Ali, and Naufal. Yes or no? What you say, Naufal?
The function.
It's a function. Okay. Yes, Alina. Is it a function? Ali?
Yes, ma'am.
Alina?
Yes, ma'am.
Let's check it. 2 is there, 5 is there, 8 is there, 11 is there, 14 is there, 17 is there. 1, 1, 1, 1 is there, no worries. One more time, 1 is there, 1. Okay, all are just 1. Just 1 is there. 2 is going to 1, 5 is going to 1, 8 is going to 1, 11 is going to 1, and 14 is going to 1, 17. One in each and every element must have its image. Condition fulfilled. Now the next condition is one input cannot generate two outputs. So yeah, one input is not generating two outputs. Basically, this is not allowed for functions. Okay, this is not allowed. But if it is reverse way, so whatever be the number, it is allowed. Okay, it will be a function. So let's check it for the other one, the next one. Can you tell me, is it a function or not? Yes, the first one is a function. Okay, it's a function because it is fulfilling both the criteria. Each and every element has a unique image, that is 1. Okay, 2 is having 1, 5 is having 1, 8 is having 1, 11 is also having 1, 14 is having 1, and 17 is having 1. Okay, check it for the next one.
Function.
This is also a function. Is it so?
Yes, ma'am. It's a function.
Let's check it. 2, 4, 6, 8, 10, 12, and 14. Here we are having here we are having 1, 2, 3, 4, 5, 6, 7. 2 is going to 1. 4 is going to 2. 6 is going to 3. 8 going to 4. 10 is going to 5. 12, 6, and 14, 7. Yeah, it's a function. Each and every element is having its image. And yeah, unique image it is having. So yes, it's a function. Next one, is it a function?
Not a function. It's not a function.
It's not a Ali. Is it a function?
No.
ma'am.
It's not a function. Here we are having 1. Here we are having 2. Here 3. Here 5. 1 is going to 3. And 1 is also going to 5. So one input is generating 2 outputs. It's not a function. We don't have to check. Suppose we are having a relation R having ordered pair 2, 2, 2, 4, 3, 3, 4, 4. Is it a function?
Not a,
It's not a function.
Yeah.
Yes, Alina and Ali.
No, ma'am.
No,
It's
ma'am.
not a function. Okay. If the first element is same, first element is exactly same, and then it is having the second element, like the best way to check it with the mapping diagram. Okay, that way you won't be getting confused. Otherwise, here there is a chance that you will forget and you will get confused. But if you will just draw the mapping diagram, it will be clear to you that yeah, it is not a function. 2 is going to 2 and 2 is also going to 4. Here only we can see one input is generating 2 outputs. That is not possible and it is not a function. Okay. Now the next concept over here, we have already discussed how to find the domain, how to find the range. Suppose we have to find the domain and range of a function f of x is there, which is having 9 minus x square. Can you tell me how to find the domain and how to find the range of this function? Just a moment. Before coming to this condition, this question, let's discuss few basic concept which is just related to function. So suppose a function is given. A function f of x is given as 2x minus 5. If we have to find f of 0, can you tell me what will be f of 0, f of 1, f of 2, f of 3? Can you tell me? The way we were finding for the polynomial, no? When px polynomial is given, then p of 1 we have to find, p of 2 we have to find, p of 3 we have to find. Same way we will be finding for the function. Okay, when x is 0, we will substitute
Minus
x
5.
as a 0. Minus 5. Can you tell me what is f of m, f of 1, Ali?
Minus 3.
Ma'am, minus 3.
Yeah, I can see you are getting it. Suppose we are having two functions. F of x is equals to, let's say, 2x minus 5, and gx we are having just a second. Let's say x square. Okay, if you have to find f of x plus gx, can you tell me what will be there? F of x minus g of x, what will be there? We just have to do the basic normal subtraction, addition. If multiplication is there, we have to do the multiplication of both the functions, 2x minus 5 multiplied with x square. If division is there, simple division we have to do over here. Okay, So if we have to do f of x plus g of x, basically whatever is f of x, we will write it over here. Whatever is g of x, we will write it over here and we will add it. If possible to add it, we will be adding it. Since here x square we are having, it is not possible now. But if we will be having just x, can you tell me what will be f of x plus g of x? Yes. Naufal, Alina and Ali, fx plus gx will be?
2x minus 5 plus x.
Do the calculation if possible.
Ma'am, 3x minus 5.
Exactly, 3x minus 5. Okay, when it is not possible to do the calculation, you will leave it. But when it is possible to combine the like term, please do it. We are allowed. Are we allowed? Yes, we are allowed. The basic normal addition, subtraction, multiplication, division, here we have to do. Now, can you tell me what will be f of x into g of x? This one. Can you tell me? Can you tell me what will be fx gx? Multiply it. Now tell me. Distributive property we can apply, right? For doing the
2x square
multiplication.
minus 5x.
2x square minus 5x. Is it allowed over here? Yes, it is completely allowed over here. Whenever we are having two different functions, if we have to add it, we will be doing basic addition. If we have to do subtraction, we will be doing basics, algebraic subtraction. Okay, the algebraic expression you can recall. There we were combining the like term. The same way we will be doing over here. Multiplication, distributive property we can apply. Division also, the basic simplification we can do, 2x minus 5 by x. If anything will be cancelable, if it is possible, we can do that. Okay, here it is not possible, but if I will take, let's say f of x is equals to 4x minus 16 and g of x is equals to 2x. Now, can you see if we will find fx by gx, can you tell me what are we going to have? Basic simplification it is, which you must have learned, I believe, in very lower classes. The calculation of algebraic expression. Same way we have to do this. Can you tell me what will be there?
2x minus 16. 4x minus 16 by 2x, 2x and 4x.
We can take 4 common. So it will come out like this. So it will come, either you can write like this or you can write 2x minus 8 by x. Any confusion? Any confusion? Or you can also write 2 in bracket x minus 4 by x. It is answer. Getting it? Ali, Alina and Naufal.
Yes, ma'am.
Now let's come to the domain and range. Okay. Previous day we were discussing about how to find the domain and how to find the range. Okay. Domain where all the first element, that was called domain. Range, we understood. Range is just the outputs. Codomain was just completely the second set. That was codomain. Now this type of question we are having, and here also we have to find domain and range. Very patiently we will be discussing this concept because this is very important. In future also you will see we will be having a lot of different types of function where we will be finding domain and range of each and every function. Okay, So the basic criteria of function we understood. Now, if we are having a function as a under root 9 minus x square, so we have to find domain. Domain means what x value can be taken over here. Domain means what x value is acceptable over here. Just a second. So one thing we need to understand, that everything in mathematics is acceptable except few cases, few scenario where one of them is 0 in the denominator. It is not acceptable in mathematics. Okay, we call it not defined. If 2 by 0 is there, we will call it not defined. Okay, if x by 0 is there, we will call it not defined. So 0 in the denominator is not defined in mathematics. Okay, just a glimpse of that you have seen in the definition of the rational number, that every number which is in the form of p by q, where p and q both are integer and q is not 0, those are called rational number. It is not just limited to rational number. It is here also we will always be careful that denominator should not be 0. Okay, suppose we are having a function f of x is equals to 2 by x minus 3. So can you tell me what is that x value which can make the denominator 0 over here? What is that particular x value which can make the denominator 0 over here? Anyone? Alina, Ali, Nofal? 3. X value, if by mistake we will take 3, it can make the denominator 0. So here x value 3, never ever we are going to take. Okay, everything over for this function f of x 2 by x minus 3, you can take any x value, but 3 we will not take. Okay.
Any number more than 3.
What you said, Nofal?
Any digit upper than 3. Like 4.
Yeah, lower than 3 is also okay. Lower than 3, suppose you are taking a number x equals to minus 2. Or maybe x equals to minus 1. Let's check it. 2 by minus 1 minus 3. 2 by minus 4. It is okay. A number, the value can be negative number, positive number, 0. Everything is okay. But this 3 is making it not defined. We will avoid this 3 in this scenario. So that much important is this concept that denominator should not be 0. Okay, not only for the function, always we will say in mathematics that denominator should not be 0. Okay, and one more concept is there, that inside the square root, negative should not come. If you are having inside the square root, inside the root sign, if you are having a negative number, let's say minus 2, let's say minus 36, a perfect square number also, this is also not acceptable in mathematics. So two scenario as of now, 0 in the denominator is not acceptable and negative sign inside the root is not acceptable. Okay, apart from that, you can take any x value. We are free to take any x value. Now let's find the domain and range of this function. When previously we were finding the domain and range, then it was very simple. Our set was defined, our ordered pair was defined, and we were just picking the first element. So if it was like this, then we were just saying that this 2, this 3, and this 4 is the domain. Okay, and 4, 6, 8 is the range. Or if the second set is the same, we were saying this is the codomain also. Previously, it was so simple because our set was defined. Set A is having just few elements, let's say 2, 3, 4. Set B is having just like A, B, C, D, or maybe E also. So previously our set was very limited set, but now we will start thinking about a set of natural number, set of real number, set of whole numbers, okay, set of integers which we will represent with the letter Z called set of integers. So now we have to broaden our sets. Now we are not having finite set. Now we will be talking about infinite set. Set of integer, it's infinite set. Set of whole number, natural number, real number, irrational number, rational number. These are infinite set. So now we will be talking about infinite set. And considering infinite set in mind, we are going to define the domain and range. Let's get back to our question. Here we are having a square root of 9 minus x square, and we are searching what can be the possible x value. Oh, is that possible to take any real number as a x value? Will that be okay? Can we take x as any real number? No, because the square root is there, so we have to be careful. Inside the square root, negative numbers should not come. Inside the square root, whatever is there inside the square root, whatever is there, that should not be negative number. That has to be greater than or equals to 0. If inside the square root equals to 0 is there, fine. If inside the square root bigger number than 0 is there, fine. But negative number we are not going to take. That's why we have written whatever is there inside the square root, it has to be greater than or equal to 0. Am I making sense to you, Alina, Ali, and Naufal, so far?
1, 2, 3. That's all.
Yes, ma'am.
Okay. So to find the domain, now only we discuss what is not acceptable in mathematics, and now we will keep in mind that inside the square root, everything we can, x value can be any number, but we will keep in mind that negative should not come inside the square root. After taking any x value, we must not get negative result inside the square. How to think about those number? We will, if you will start thinking, you will keep on thinking and keep on thinking. It will just take a lot of time. So better you write it like this.
2, 3. So
Yeah, we can take 1, 2, 3 like that. So if you 1, 2, 3, and what else? So we are not sure. 4 we can take.
no.
Let's check it.
4 square.
4 square is 16. We cannot take 4. 4 we cannot take. 4 square is 16. 9 minus 16 is a negative number. Yes or no? We cannot take 4. Okay, so just a rough idea, we are getting that 1 we can take, 2 we can take, 3 we can take, 4 we are not able to take. Okay, 5 still it will be 9 minus 25 we cannot take. What about the negative number? 0 we can take. 0, x value can we take as a 0? 9 minus 0 is square. It's just 9 only. Yeah, we can take 0. Okay, we can take 0. We are just avoiding the scenario where we will end up having a negative number inside the square root. Okay, 0 is acceptable, 1, 2, 3 is acceptable, but 4 is not acceptable. Here we are writing it. X value 0, we have checked it is acceptable. X value 1, 2, 3, we have checked it is acceptable. But when we started taking 4, 5, 6, it was not acceptable. So after 3, whatever number we are going to take for x, it is not acceptable. What about the negative numbers? What about the negative numbers? All the negative numbers are acceptable. Minus 1, can we take?
-2.
Yeah, minus 2 also we can take. Minus 3 also we can take. Ali, what else we can take? Minus 4 we can take, Ali?
No, ma'am.
No.
Yes, ma'am.
Again, it
No, no.
yes. Yes or no?
No, ma'am.
When we will do
No,
minus 4 square, it will be plus 16. Again, 9 minus 16, it will create a negative number inside the root sign, which is not acceptable. So this is giving us a rough idea that these are the number which is fulfilling the criteria and which number we must not take. But if we will do like this, exactly we will be getting the what will be the interval. So what we can take, whatever is there in the square root, that has to be bigger than 0. or equals to 0. Now we will completely focus on solving this inequality. There is a chapter called inequality. Okay, let me explain some concept which is related to that chapter, because we need, again and again we will be finding domain and range over here, and you need to know basic of that. So there are four inequality signs. Inequality. Okay. Equation means that there must be a equality sign. Now we are going to talk about inequality sign. There are four inequality signs: bigger than, okay, larger than, smaller than. Next one is greater or equals to, and next one is lesser than or equals to. Listen to me carefully how I am pronouncing it, how I am calling it. It is called greater than or equals to, either greater than or equals to, and this is called less than or equals to. Okay, these are four inequality sign we are having. The first two is already known to you. The next two is the combination of equality also and bigger than sign also. Okay, and then there is a, so suppose we will be having, now we will you need to know the basic of solving the inequality. So suppose we are having, just let me take one inequality so that quickly we can do this one and we can get back to our question. Yeah. Just a second. Suppose we are having one inequality. Let's say 5x plus 9 is smaller than 7x plus 3. We have to solve this inequality. Okay. So the way we solve the equation, no, same way we will be solving the inequality. The way we solve the equation. Okay. If there will be equal to sign, how you find the value of x? Here, like that only we will be solving this inequality. So what we will do, we will just collect all the variable on one side and we will keep constants on the other side. So this 7x we can take to this side. It will be 5x minus 7x. Okay. The sign we will maintain as it is. 9 will go to other side. We will transpose it just like an equation. Okay. 3 minus 9 on the other side. Now, can you tell me what will be there on the left side? 5x minus 7x is?
Minus 2.
Minus 2x. And 3 minus 9 is?
Minus 6.
Can you see? So far, whatever we have done, it's exactly like the equation, the way we solve the equation. Can you see it? But now we have to be careful. Now we have to be careful whenever we are going to do the division or multiplication by a negative number. We have to reverse the sign. Okay, this minus 2 we will transfer to other side. That means we are going to divide by a negative number. So either we have to divide by negative number, or maybe we have to multiply by a negative number. In this two scenario, we have to reverse the sign. Why we are doing so? I am coming to that. So it will be minus 6 by minus 2, just like the equation only. Okay, division, multiplication will be division. But at the same time, we have to reverse this sign. This sign will get reversed to this sign. Only here, only this is the only place where we have to be careful. Why? Because let me give you example. Suppose you are having two number, 2 is smaller than 3. Everyone agree with that? 2, the number 2 is smaller than the number 3. Yes or no?
Yeah.
Yes or no? When you will add the same term on both the sides, 2 plus 1, 3 plus 1. It will become 3 on the other this side and 4 on the other side. Still we have to maintain the same sign, right?
Yes.
When we will be subtracting a certain number, let's say 2 minus 2 and 3 minus 2. So 2 minus 2 is 0, 3 minus 2 is 1. Still we have to maintain the same sign. Can you see? Still we are maintaining the same sign. When we are adding certain number on both sides, subtracting a number on both sides, same sign we will be maintaining. What about multiplication and division? So 2 is there, 3 is there, smaller than sign is there. If you will multiply 5 over here and you will multiply 5 over here, can you see 5 2 times 10 and 5 3 times 15? Still it is less than sign. Yes or no?
Yeah.
Like this only, if you will do the division by a same number, same sign you have to maintain. Where you have to be careful when you are doing the multiplication or division by a negative number. So suppose instead of 5, we are going to do the multiplication by minus 5. 2 is smaller than 3. Here also you will do multiplication by minus 5. Here also you will do multiplication by minus 5. Can you tell me minus 5 into 2 will be? 10. Minus 10 or plus 10?
Minus 10.
Minus 10. Minus 5 into 3 will be?
Minus 15.
Minus 15. Now, if I will maintain the same sign, is it true? Minus 10 is smaller than minus 15? Minus 10, the number is smaller than minus 15? Minus 10, minus 15 से छोटा है? Yes or no?
No.
No. Minus 10 is not smaller than minus 15. It is bigger than minus 15. Okay, this sign is incorrect. Here we must reverse the sign. That's why I was telling you that when we will be solving the inequality, everything will remain same. But when we are just doing the multiplication or division by a negative number, we have to reverse the sign. So this sign will get changed to this one. Okay, this sign will reverse to this sign. Okay, greater than sign will reverse to lesser than sign. Greater equals to sign will reverse to lesser equals to sign, and less equals to sign will reverse to greater equals to sign when we are multiplying or dividing by a negative number. Suppose we are having x by minus 2 bigger than 3. If this minus 2 you will shift to other side, can you tell me what are we going to have? X this minus 2 will be in multiplication on the other side, yes or no? Yes or no? Can we say the sign will get reversed since we are multiplying by a negative number?
Yes.
Only here. This is the only place where you have to be careful. If you got it, you will find that the whole inequality chapter you are able to solve by yourself. So this is just a quick, like the basic of inequality, which we are going to use over here. Let's use it. 9 minus x square is larger than or equals to 0. Let's solve this inequality. Is it possible to do the factorization of 9 minus x square?
Yeah.
What can be written? 3 plus x and 3 minus x can be, right?
Yeah.
Can be. 9 means 3 square. A square minus b square format. Can you see? Ali, Alina?
Yes, ma'am.
Okay, so a plus b, a minus b, we have written over here. Okay. Now what we will do? when we were solving the quadratic equation like this, then we were getting the x value from here. What was the x value? When suppose you are having 3 plus x, 3 minus x is equals to 0. Can you tell me what is the x value? Yes, 3 plus x in one bracket and 3 minus x in another bracket is equals to 0. Then x value will be, if you have solved a quadratic equation or anything and you got this factor 3 plus x,
3,
3 minus x is equals to 0. X will be
3,
3 and Alina,
minus 3.
yeah, whenever we are having something into something is equals to 0, can you recall we were taking that first bracket is equals to 0 and the second bracket is equals to 0? Can you recall? Suppose we are having x square minus 5x plus 6 is equals to 0. This quadratic equation, when we are solving, we are getting x minus 3, x minus 2 is equals to 0. Can you tell me what is the x value?
3 and 2.
3 and 2. So from where this 3 and 2 came? From where this 3 and 2 came? Mathematics says that whenever two things are in multiplication and the result is 0, whenever two spaces are there, like the blank space are there and the result is 0, then the possibility is either this one is 0, either this one is 0, or maybe the other number is 0, then only the result can be 0, or the other number is 0, or maybe both are 0, or maybe both of them are 0, then only the result is 0. Okay, when you think about it, you are having two different number. Okay, maybe two like whole numbers, two decimal number. Is it possible that you will do the multiplication and result will come out as a 0? Is it possible? You can take any decimal numbers or maybe a whole number or maybe integer. Is it possible that if two numbers which are not 0 but the result will be 0 after doing the multiplication, is it possible?
No.
No. ऐसा कभी भी पॉसिबल नहीं है कि हमारे पास टू नंबर्स है और दोनों में से कोई भी 0 नहीं है लेकिन रिजल्ट 0 आ रहा है मल्टीप्लाई करके. ऐसा पॉसिबल ही नहीं है. ओके, तो जब रिजल्ट 0 आ रहा है, दैट मीन्स वन ऑफ देम हैज टू बी 0. ईदर द फर्स्ट नंबर इज 0 or the second number is 0, or maybe both number are 0, then only the result after multiplication we are getting as a 0. Understood? And that's why you, whenever in, like not only in quadratic equation, whenever you will be getting, let's say 2x minus 3 and then one of the bracket will be x plus 5 is equals to 0, logically, mathematically, you can take either the first bracket is 0 or maybe the second bracket is 0, because the result is 0. So maybe the first term is 0, or maybe the second is 0, or maybe both are 0. From here only we are getting the x value. So we are not using any formula or rule over here. Logically we are thinking that when the result between two terms multiplication is 0, that means this is the possible cases. Getting it? Okay, now if I will ask you, don't worry, I will summarize everything over here. Where is the question? Yeah. We did the factorization. Okay. Now, can you tell me the x value which we can get if we will be having equals to 0? Can you tell me the x values? 3n. X value is 3n. Alina, x value will be 3 and what else?
-3.
-3.
-3. X value will be 3 and also minus 3. Let me write over here. And here we have drawn the real line that consists of minus infinity to plus infinity. Okay. Now you can see here we are having 3 different intervals. Okay. Which 3 intervals? This is one of the interval. This is second interval. This is third interval. So real line which consists of minus infinity to plus infinity, we are able to divide that in 3 intervals. One of the interval is minus infinity to minus 3. Another interval is minus 3 to only 3, positive 3. And another interval is 3 to infinity. Okay. We have divided our real line in 3 intervals. Now in each interval, we will be taking a test point and we will be checking whether our inequality is correct or not. So let's take the test point in each interval. Okay, let me keep it like this. Let's take the test point in each interval. So in between minus infinity to minus 3, let's take a test point. Which number you want to take? Test point. माइनस इंफिनिटी से माइनस 3 के बीच में कोई नंबर लो, कोई भी रैंडम नंबर. 0? No. Minus 4? Minus 5? Minus 6? Which number? Minus infinity to minus 3. Which number you want to take? Are you able to understand? Here minus 4 will be there. Here minus 5 will be there. Minus 6 will be there. Minus 10 you said? Yeah, let's take minus 10. If we will be substituting this test point, which randomly we have taken in between minus infinity to minus 3, minus 10 we have taken. If we will substitute it in this inequality, which we have got as a last step, 3 plus x and 3 minus x. Okay, 3 plus x and 3 minus x larger than or equals to 0. At the place of x, if you will substitute minus 10, okay. Can you tell me, will it be true or false? कैसे check करते हैं? Let me show you. Okay, how to check it? Let me show you. Because again, when you will give the competitive exam, teachers will expect that these are the basic concepts you already know. These are the basic concepts which you must know, but you will feel that directly you have written the domain, you have not understood the process clearly. So you need to understand. Okay, if in future you want to give any competitive exam, if you want to understand the concept clearly. So we were having 3 plus x and 3 minus x greater than or equals to 0. Okay, x value randomly we have taken minus 10 and we are calling it a test point. Test point. Now, if you will substitute minus 10 in this bracket, the result will be negative. Yes or no?
Yeah.
If we will substitute minus 10 in this bracket, the result will be positive. Yes or no?
Yeah.
And the multiplication of a negative term and a positive term will be
Negative.
negative. Negative number. Okay, greater than or equals to 0. Is it true or false? True or false? Vote for true or false. False.
False.
It is false. So this interval we are not going to take. The interval which we are having from minus infinity to 3, this interval we cannot take. Like that only you have to check for other 2 intervals also. The interval which is in between minus infinity to minus 3, we cannot take that interval. Every time we will be analyzing our domain like that only. This interval is not acceptable. Check for the other interval minus 3 to 3. Take one test point and check your inequality is true or false. You can take a test point 0 over here. That will be simpler. Now, when you will substitute 0 over here, 0 in the first bracket, it will come out as only 3. 0 in the second bracket, it will come out as only 3. Will it be true or false? True. So yes, we are going to take this reason. We are going to take this reason. In between minus 3 to 3, we can take this reason. Okay. Let's check the other interval also, 3 to infinity. Let's take a test point randomly, any test point. Let's take 4. Okay. If we will substitute 4 in the first bracket, the result will be positive or negative. Tell me. We don't have to do the calculation. Positive. If we will be substituting 4 in the next bracket, the result will be positive or negative.
Negative.
Negative. And a positive number multiply with a negative number, the result will be
Negative.
negative number. Is it true that negative number
False.
greater than or equals to 0? False. So this reason also we cannot take. We understood that only one interval we can take, that is -3 to 3. Now set chapter, if you have done, you are having the idea that there exists interval, close interval, open interval. So will it be close interval or open interval? So check it. If we will be taking -3, is it true or false? If you will be checking from here, if you will take x as a -3, will it be true or false?
True.
It will be true because there is a equality sign also. Okay, it will be true. If you will take 3 also, then also it will be true. So yeah, close interval, this is the domain. Let me summarize everything quickly. Our function is under root 9 minus x square. Inside the square root, negative sign, not acceptable. Negative number, not acceptable. So whatever is there inside the square root, whatever is there has to be greater than 0. And even if it is equals to 0, fine. Okay. Now we will try doing the factorization. We are getting 3 plus x. We are getting 3 minus x larger than or equals to 0. Now we will draw the real line to check which interval is acceptable and which is not. Real line consists of -infinity to +infinity. From here, two values we are getting. Okay. One is -3, another is 3. This is how we are getting 3 intervals. One is -infinity to -3, another is -3 to +3, another is 3 to infinity. Now in this 3 interval, what we will do, we will take a test point over here. Test point, it was not coming out as a true. Here also we have taken a test point. It was not coming out as a true. Here we have taken one test point and it was true. That means this interval is acceptable. -3 to 3 is acceptable. We have also checked with the end point, the inequality is true or false. It was coming out as a true because here equality sign is there. That means it can be equals to 0 also. So when we have taken x value as a 3 or maybe -3, we were getting equals to 0. Everything over here is becoming 0 and equality sign is there. So true. So that's why our domain is -3 to 3. Is that clear to everyone over here? Is that clear? Naufal, Alina and Ali. Is it clear?
Yes, ma'am.
Next, I will send you a few square root functions, domain you have to find. Do it like this, okay? And let me know in the next class whether you were able to do one. Function we have already covered. There are some special function which we will complete in our next class. In our next class, we will finish this concept. So today I'm keeping it this much. Let's continue it. In the next class, one more class and we will be done. Okay, yeah, one more class we need for this one. Any doubt? Whatever we have discussed so far from there, any doubt? Anyone having any doubt? Please don't memorize the steps. Try to understand the concept. Any doubt, Ali, Alina and Naufal?
Um,
No, ma'am.